Welcome. So in this video, we'll learn about the basis of selection of indicators. Basis of selection of indicators. So which type of indicator is used during any acid-base titration? Their selection criteria we will learn in this video. So we have four cases which are possible when we are doing acid-base titration. Either we are titrating strong acid with strong base, the graph will be like this, or we are titrating strong acid with weak base, the graph will be like this, or we are titrating weak acid with strong base, graph will be like this, or we are titrating weak acid with weak base, the graph will be like this. So all the four cases we will learn now one by one. Now the first case is strong acid by strong base. Say strong acid is HCl and strong base is NaOH. Say we take conical flask and then we add HCl in it. Say 10 of HCl we are adding, and then we are titrating with NaOH. Then graph will be like this. Initially, because HCl is having lower pH, so pH will start at lower pH, and then the pH will increase slowly until at this point the pH will increase very fast. That is, this is the steep region of the curve, and then again the curve will be like this. That then pH increase will be slow here. So this type of behavior which is shown when the strong acid is being titrated with a strong base. Okay, so initially, so this is called the steep region of the curve. This is called the steep. So which indicator I should use for this titration? So my answer is that which all indicators which are having the pH range, their pH range in this area from this point to this point can be used here. So all the indicators which having pH range in the range, that is they're having pH range in this region, that is from this area, this point to this point, that's the steep region of the curve. This is the steep region of the curve, can be used for this type of reaction. So to know the equivalence point, any indicator which is changing its color in this region from this point to this point can be used. Now let us see which other indicators are there. Say methyl orange and methyl red having pH range in this region. Phenolphthalein is having pH range in this region. So phenolphthalein can also be used, or methyl orange can also be used as indicator. But since there is sharp change in the color determined using phenolphthalein, so phenolphthalein is generally used for strong acid, strong base titration. Now if we see here why because we equivalence point is 7, and then we are using the indicator whose endpoint is say phenolphthalein is having endpoint at 8.3 approx, and why phenolphthalein is used for indicator although is having endpoint as 8.3. So question is that why phenolphthalein is used as indicator during strong acid strong base titration although it is having endpoint at 8.3, and we are interested in knowing the point 7, that is the equivalence point. The reason behind it, because in this equivalent point, so if we see there, if you here up to from here to here, so we can say there is minor change of volume. So only one or two drops by adding 1 or 2 drops, there is a significant change in the pH. We can see that steep region pH is increases so much. So all the indicator, so if we are I'm using phenolphthalein, then it will after 1 drop it will give me the point that indication that the reaction has taken place, completed. And in case of methyl orange, 1 drop less. If I am using methyl orange indicator, then one drop less will indicate that the reaction has completed. So in either case एरर इज नेग्लिजिबल, दोनों केस में एरर नेग्लिजिबल होता है. तो मैं एक बार रिपीट कर देता हूँ. इस पॉइंट से लेकर इस पॉइंट तक एक या 2 ड्रॉप का ही डिफरेंस होता है और पीएच सिग्निफिकेंट चेंज हो जाती है. तो जो भी इंडिकेटर इस डीप रीजन में हमारा यूज़ कर सकते हैं, जिसका पीएच रेंज इस डीप रीजन में फाल होता है, मैं वो स्ट्रॉन्ग एसिड और स्ट्रॉन्ग बेसिस टाइट्रेशन के लिए यूज़ कर पाऊंगा. जैसे फिनोप्थलीन मैं यूज़ कर सकता हूँ, मिथाइल ऑरेंज कर सकता हूँ, मिथाइल रेड कर सकता हूँ. जो भी इंडिकेटर जो है इस डीप रीजन में फाल होंगे, मैं वो स्ट्रॉन्ग एसिड स्ट्रॉन्ग बेस के लिए मैं यूज़ कर सकता हूँ. अगर हम दूसरा केस देखें, स्ट्रॉन्ग एसिड और स्ट्रॉन्ग बेस. स्ट्रॉन्ग एसिड का एग्जांपल हमने ले लिया HCl, और वीक बेस का हमने एग्जांपल ले लिया है जैसे अमोनिया ले लिया है. तो अगर मैं अमोनिया यहाँ से ऐड करता हूँ तो इनिशियली जो पीएच जो ग्राफ स्टार्ट होगा वो क्योंकि एसिड स्ट्रॉन्ग है तो लोअर पीएच पे स्टार्ट होगा और धीरे धीरे पीएच बढ़ेगी और एक पॉइंट पे क्या होगा, जब आप देख सकते हैं यहाँ पे स्टीप रीजन जो हो जाता है, पीएच जो है ड्रास्टिकली इंक्रीज हो जाती है सिर्फ एक ड्रॉप से. ठीक है, दैट इज देर इज ओनली वन और मोर, एक ड्रॉप डालते ही या दो ड्रॉप्स ज़्यादा, मैक्स एक या दो ड्रॉप विच इज इनसिग्निफिकेंट, ठीक है, जो कि ज़्यादा एरर कोज नहीं करेगा, एक ड्रॉप ही पीएच को इतना ज़्यादा चेंज कर देता है। ठीक है, तो हम देख सकते हैं ये जो रीज़न है, ये क्योंकि स्ट्रॉन्ग एसिड है तो ये जो भी इंडिकेटर इस पीएच रेंज में जिनका पीएच रेंज इस रीजन में होता है वो हम इंडिकेटर यूज़ कर सकते हैं। तो फिनोप्थिलिन नहीं हो सकता क्योंकि फिनोप्थिलिन का एंड पॉइंट जो फिनोप्थिलिन का जो पीएच रेंज है वो आपका 8 to 10 होता है। तो फिनोप्थिलिन हम इस टाइट्रेशन के लिए हम यूज़ नहीं कर पाएंगे। हम जो यूज़ कर पाएंगे क्योंकि फिनोप्थिलिन का चेंज यहाँ पे कलर हो रहा है, और अगर मुझे वो यूज़ करूँगा तो आप देख सकते हैं कितना वॉल्यूम मुझे डालना पड़ेगा, तब जाके आपका जो है चेंज होगा, और वो जो है बहुत ज़्यादा एरर दिखाएगा क्योंकि हमें इक्विवेलेंस पॉइंट देखना है। तो इक्विवेलेंस पॉइंट जो है आप देख रहे हैं स्टीप रीजन में फॉल हो रहा है, तो जो इंडिकेटर, जैसे मैं यहाँ पे मिथाइल ऑरेंज यूज़ कर पाऊंगा और मिथाइल रेड भी यूज़ कर पाऊंगा। ठीक है, तो दिस इज द सेकंड केस इन विच वी आर टाइट्रेटिंग स्ट्रॉन्ग एसिड विद वीक बेस. So weak base is here ammonia, and we can see that the methyl orange and methyl red are suitable indicator in the case of titration. Now see the another case which is weak acid and strong base. The example of weak acid is say acetic acid CH3 COH. Strong base say NH is there. Okay. Now you have taken acetic acid in a conical flask and then you are titrating with NaOH. So initially pH will be lower. Obviously the pH will be lower for acetic acid, and then you are adding NaOH slowly, and then initially here we can see that there is NaOH, there is a small increase in pH, and but at this point there is a rapid change in pH which happens. This is the steep region of the curve. So any indicator which is having pH range in this region can be used for this titration, and the HPS, that phenolphthalein indicator, is having the pH range of 8 to 10, and so can be used for weak acid and strong base titration. Okay, so here even a single drop, so a single drop will change the rapid change in pH. So volume, you can see there volume is very less, and then pH change is very significant. So any indicator which can change the pH range in this region can be used for this titration. And if we are say if we are making use of methyl orange, say methyl orange will changing color and equivalence point is here. So see how much volume change is there. So there will be and error will be there. So methyl orange cannot be used. So methyl orange is not falling, that pH range of methyl orange is not falling in this deep region of the curve. So that methyl orange or methyl red indicator cannot be used. Only phenolphthalein indicator can be used for this titration. Then coming to weak acid and weak bases. Now if we take the example of weak acid, say acetic acid is there, and weak base, say I am taking ammonia, and the graph will be like this. So there is no steep region in the curve. I am not having any steep region for this curve. So if I am making use of any indicator, that will give me a drastic error. So methyl, say if I am using methyl orange, the color change will be here, and then if say phenolphthalein I am using, the color change will be here, although the equivalence point is coming here. So there will be, see, you can see here there will be significant error will be there, large error will be there. So if you are using an indicator, so we are not using any indicator, no suitable indicator is there to titrate weak acid with weak base. So generally we are making use of pH meter. So if we titrate weak acid, we can make use of pH meter to know the equivalence point. Otherwise there is no suitable indicator is there to titrate weak acid with the weak base, as there is no steep region in the titration curve of the weak acid versus weak based. So as we have seen here, so this way we can select what is the basis. So the question is, what is the basis of selection of indicators during acid base titration? So you have to mention that four cases are there: strong acid, strong base, strong acid, weak base, weak acid, strong base, and weak acid, weak base. And then you have to show that which all indicators are suitable for each type of titrations, and those indicators which are having pH range in the steep region of the curve can only be used. And in case of weak acid and weak base, that is no suitable indicator is there to indicate that the equivalence point has been reached. So I'm again repeating that two terms: one is equivalence point, other is end point. So equivalence point is the point at which the number of moles of the acid becomes equal to the number of moles of the base. That is the equivalence point. At the point that when the number of moles of acid or number of moles of number of equivalents of acid becomes equal to the number of equivalents of the base. Whereas endpoint is the point where a indicator is changing its color and indicating that the reaction has completed. So endpoint is related to indicator, where the indicator is changing in its color and is indicating that the reaction has taken place. So there is difference between the equivalence point and the endpoint. For example, when we are doing strong acid and strong base titration, the equivalence point is at pH 7, but the phenolphthalein is changing and endpoint changing its color at 8.3. So endpoint is 8.3, whereas the equivalence point is pH 7. And since we can see that why it is used an indicator, then because if we are using it is indicating correctly the equivalence point, as a single drop is not affecting the results, because there is no change in the pH with a single drop change in the alkali, we have the significant change in the pH. So phenolphthalein is the best indicator, because also there is happening that is change in color. Although methyl orange can also be used because this is also falling the steep region, but phenolphthalein is generally used because it is giving the sharp change in color. Okay, so question is why phenolphthalein is used as an indicator during strong acid strong base titration, although it's having endpoint at 8.3. The reason is that at 8.3, although it's changing the color at 8.3, but it is correctly indicating the equivalence point, as a single drop is not changing the significant, is not a major error, and then that is indicating that the equivalence has risen. Although we are at pH 8.3, we can see that the equivalence point is also attained, and there is no significant error in the volume. Okay, so that is why, and also that is a sharp change in color, so we are making use of phenolphthalein as indicator, although it's having endpoint at pH 8.3. Okay, now so let's just see the indicator, their pH range, and then the color change which they're showing. So we have methyl orange, the pH range is 3 to 4.4. In acidic solution it is giving red color, and then basic it is giving the yellow color. Methyl red is giving pH range 4.4 to 6.3. In acid it is giving red color, and base it is giving yellow color. Chromothiamol below 6.6 to 7.6. In acidic conditions it is giving yellow color, in basic condition it is giving blue color. Litmus is having pH range 6 to 8. That in acidic condition it is giving red color, and basic condition it is giving blue color. Phenolphthalein is having pH range 8.2 to 10. That it is colorless in acid, and then in pink color in base, that we know. So for any strong base acid, strong base and titration, any indicator which is changing color from 3 to 11, any indicator which is changing color 3 to 11 can be used. Okay, so mostly we are making use of phenolphthalein as indicator. Okay, so we can use methyl orange also, methyl red also, phenolphthalein also, but mostly we are making use of phenolphthalein because it's giving sharp change in color. The second case is strong base and weak acid. In the strong acid weak base titration, I've seen that any indicator which changing color nearer to 9.5, that is near to 9.5, that can be used. For example, phenolphthalein can be used here in this case. Then weak acid and weak strong acid titration is there. So any indicator which changing in color in the range of pH 3 to 6 can be used, and then methyl orange or methyl red is being indicator which is being used. And then for weak acid and weak base titration, there is no suitable indicator is there which can be used because there is no steep region which is observed in the titration curve of a weak base and weak acid. So in this video we have learned what is the basis of selection of indicator during any acid base titration, and which indicator to be used when depending on the type of acid or type of bases which are being used during the titration. Thank you.